Hey student, welcome back to lecture series on statistic. In my today's video, I'm gonna explain to you all the harmonic mean for group data and ungrouped data. For similar videos, guys, go ahead and check in my playlist, or you can see in my description box. You will get the entire playlist, or you can check in I button over here. Okay, so without further ado, let's get dive into our today's lecture. I'm gonna explain to you all the harmonic mean for the two types of the data sets. For example, we go for it later on. Just need to understand the descriptive method. Okay, so what actually the harmonic mean? You already learn in your 11th 12th harmonic progression. Okay, so try to relate the concept. Harmonic progression you learn. If you have 1 upon denominator, is it into the arithmetic progression, so we consider it as the harmonic progression. Okay, for the geometric mean it is the similar. Okay, so whenever we have harmonic mean, okay, a number of observation is the reciprocal of arithmetic mean. Okay, number of observation is the reciprocal of arithmetic mean of the reciprocals. Okay, of the reciprocals. That means whenever we have denominator, it is in the arithmetic mean, so we consider it as the harmonic mean. Okay, yes, let me write for the formula for arithmetic harmonic mean. Okay, reciprocal of arithmetic mean of the reciprocals. Okay, that one need to remember for the harmonic mean. Okay, for first we go for the grouped data, for ungrouped data. Okay, for ungrouped data. Okay, if you are still confused in the definition of harmonic mean, guys, I'll explain to you all in the simple language. Harmonic mean means a number of observation is the reciprocal of arithmetic mean of the reciprocal of arithmetic mean of the reciprocal. That means whenever we have denominator, it is in the form of arithmetic mean. Okay, then we consider it the harmonic mean. Yes, so for ungrouped data, let me write harmonic mean. Okay, for harmonic mean ungrouped data, we write harmonic mean as n number of observations, okay, divided by 1 upon x1. Now see that we got the reciprocal as a denominator plus 1 upon x2 plus 1 upon xn. Okay, this one complete. See that 1 upon x2 xn is like a series form, so we can sort it into the form of a series. Okay, so we write harmonic mean as a n upon series 1 upon xi. I is equal to 1 to n. Okay, I is equal to 1 to n. See that this one is our harmonic mean for our ungrouped data. For ungrouped data, I which is equal to 1 to n, numerator here n, okay, denominator 1 upon xi. Okay, so I just written this one into the some series form. Numerator n is as it is. Okay, this is the harmonic mean, or you can write that n to the denominator also. Okay, so how can we write this step as 1 upon completely divided by series I is equal to 1 to n, I is equal to 1 to n, 1 upon xi. Okay, and completely divided by n. Okay, this one is also the harmonic mean. What I have done actually here, I taken that numerator here. Okay, so we know that denominator of a denominator, it goes to the numerator. Okay, so you can take this way or you can take this way, both are correct. Okay, yes, this is for ungrouped data. Okay, let's go for the grouped data. For grouped data, okay, we want the harmonic mean for the grouped data. So always remember that whenever you get the group data means a class interval with a frequency, you will get it there. Okay, so if x1 to xn are corresponding frequencies, f1 to fn. Okay, x1, okay, x2, x3 up to the xn, which has corresponding frequency f1, f2, f3 up to the fn. Okay, these are the corresponding frequency we have given. Okay, then we write harmonic mean. Directly I'm going to write using this one. Okay, it is way easier, not the difficult. Okay, we write harmonic mean for these frequencies and class intervals So we have n, that instead of that we take summation. N means what is here, number of observation, and in the frequency we take summation of fi. Okay, means capital N as the numerator. Don't get confused, summation of fi means capital N is there. So this is n number of observation, this is n number of frequencies. Okay, but this is the summation of n number of frequencies divided by f1 by x1. Okay, that means f1 by x1 plus f2 by x2 plus fn by xn. Okay, plus f2 by x2 plus fn by xn. Okay, this one is the bracket complete. Now see that this one we refer as a harmonic mean. Okay, so let's write in some short form. Okay, capital N, write here as capital N only numerator. Okay, and this is some sort of a series. So write a series I which is equal to 1 to n, I which is equal to 1 to n, fi by xi, fi divided by xi. This is our required harmonic mean. Okay, for the grouped data. I hope you all have guys understood. It's not that difficult, it is way easier, but just remember summation of I is n. Okay, this is the harmonic mean for the grouped data, and this is the harmonic mean for the ungrouped data. These are the result guys, very much important, that we are going to apply it for the subsequent example. This first result, and this one is the second result. Okay, you can take this one also, this one. Keep these results in your mind. If you don't know, you can prepare it by using your basic concepts. Okay, I hope you all have understood guys harmonic mean. That's it for our today's lecture. So for similar videos guys, go check in my description box, or you can check in I button here. Okay, yes, so that is for my today's lecture. I hope you all have understood everything. Even after, if you found anything difficult guys, let me know in my comment section. I will come up with the similar videos. So thank you everyone, thank you for my today's lecture.